Hello everybody, my name is Sebastian now from Student Math, and today I will be showing you an example of how to solve an ellipse. Now before this video starts guys, make sure you like and subscribe and comment down below if there's any other math problems or any type of math concepts you'd like me to show you how to do next. So yeah, I hope you guys enjoy. So here we're given the equation 25x squared minus 150x minus 75 equals negative 16y squared minus 64y plus 36. In order to solve this, to see what type of conic it even is in the first place, we're going to need to rewrite in the general form of a conic. So we're going to get all of the x and y terms on the left side of the equation and all of the constant terms on the other side. So we're going to end up with 25x squared plus 16y squared minus 150x plus 64y equals 111. Now notice the first two terms on the left side are the ax squared and the cy squared terms in the general form. And because we can see that a times c, that's the coefficient of the x squared times the coefficient of the y squared, is greater than 0, as they're both positive, and a does not equal c, this tells us that this conic is an ellipse, and we can go on solving it as such. Our next step in solving this ellipse is getting this equation into the standard form of an ellipse. So the first step is to group the x terms and the y terms together on the left side. And what we're going to do is factor the greatest common factor, GCF, from the x terms and group them together in parentheses, and do the same for the y terms and group them together in parentheses. The next step is to use completing the square. And what we're going to do is add 9 on the inside of the first set of parentheses on the left, and add 4 on the inside of the second set of parentheses on the left. Now notice, even though we're just adding 9 and 4 inside of each of the two respective sets of parentheses, what we're actually doing is adding 25 times 9 and 16 times 4 to the left-hand side. So in order to keep the equation equal and balanced, we're going to do the same on the right-hand side. Now, what completing the square did was give us two perfect square trinomials on the left-hand side. So what we're going to do is factor those perfect square trinomials to binomial squared form. The first perfect square trinomial will factor to x minus 3 squared, and the second trinomial will factor to y plus 2 squared. And when you combine the like terms on the right-hand side, the left-hand side will be set equal to 400. Now, the next step, in order to get this into the standard form of an ellipse, is we're going to need to divide both sides by 400 so that the left-hand side with all of the variables is set equal to 1. So we're going to divide the whole problem by 400, which on the left will give us the quantity x minus 3 squared over 16 plus the quantity y plus 2 squared over 25, and that'll equal 1. Now, what we can do is rewrite those denominators as 4 squared and 5 squared respectively. Now that we have the equation in standard form, we can easily look at the left side and determine what the center of the ellipse is. The x-coordinate of the center will be subtracted from the x variable in the left fraction on the left-hand side, and the y-coordinate for the center is being subtracted from the y variable on the right fraction. So, in the left fraction, we have x minus 3 quantity squared. That means the x-coordinate is positive 3. And in the other fraction, we have y plus 2, which is actually, in this case, y minus a negative 2. So the y-coordinate for the center of the ellipse is negative 2, meaning the full coordinate for the center of the ellipse is 3, negative 2. So the next step in finishing solving this ellipse is figuring out what type of ellipse we actually have, whether that's a vertical or horizontal ellipse. And we determine this by looking at the denominators of the two fractions in standard form. So our two denominators are 16, 4 squared, in the x fraction, and 25, which is 5 squared, in the y fraction. The fraction with the greater denominator tells us which direction the ellipse's major axis runs. If it's in the x fraction, then the major axis will run horizontally in the x direction, making it a horizontal ellipse. And if the greater denominator is in the y fraction, that means that the major axis runs in the y direction, the vertical direction, and the ellipse is a vertical ellipse. So in this case, the y fraction has the greater denominator. So we have a vertical ellipse here, which means the major axis runs vertically through the center of the ellipse. And the center of the ellipse is at 3, -2. The major axis will run vertically through the x-coordinate, which means that the major axis's equation is x equals 3. The minor axis runs perpendicular to the major axis through the center as well, and that equation will be y equals -2. So now that we have the major and minor axes of the ellipse, we can find the ellipse's major and minor vertices using the denominators of the x and y fractions of the ellipse equation in standard form. Our x fraction had a denominator of 16 and our y fraction had a denominator of 25. Remember, we rewrote this earlier as 4 squared and 5 squared respectively. This is because in standard form, the denominator of the x fraction is a squared and the denominator of the y fraction is b squared. And what a and b tell us are the direction, or the distance rather, in that direction from the center that the vertices lie. In other words, in this case, since our major axis is x equals 3, which is the vertical direction, we take b from the y fraction, which corresponds with the major axis, and go 5 units up, 5 units down to determine our major vertices. So our major vertices are 3, -7, and 3, 3, as they're 5 units up and down from the center. Same process is done for the minor vertices. You go left 4 and right 4 in this case, because a equals 4 in the x fraction. And we get the points -1, -2, and 7, -2 for the ellipse's minor vertices. So major vertices, 3, -7, 3, 3, and the minor vertices, -1, -2, and 7, -2. So the next step is to find the focal length of the ellipse, which is represented by the letter C. The focal length is the distance of each of the foci from the center of the ellipse along the ellipse's major axis. So in order to find this value, what we have is the equation C equals the square root of b squared minus a squared, which this is b squared and a squared from the last part of the problem. So in order to solve, we just plug those values right in. C equals the square root of 25 minus 16. And when those combine, it becomes C equals the square root of 9, which is just C equals 3. So our focal length is 3, which means each of the foci are 3 units away from the center of the ellipse along the ellipse's major axis. This means that the foci are at 3, -5, and 3, 1. So the last things we need to find before we can create a finished graph of this ellipse are the x and y intercepts. To find the x-intercepts, we take the standard form equation we solved for earlier and we set y equal to 0 and then solve for x. When we do this, we get the values 3 plus 4/5 square root of 21 and 3 minus 4/5 square root of 21. So our x-intercepts are at 3 plus 4/5 square root 21 comma 0 and 3 minus 4/5 square root 21 comma 0, which for graphing purposes is approximately 6.670 and -0.670. Now we use the same process to find the y-intercepts of the ellipse, only instead of setting y equal to 0 and solving for x, we set x equal to 0 and solve for y. So when we do this, the y-intercepts come out to be 0, -2 minus 5/4 root 7 and 0, -2 plus 5/4 root 7. And for graphing purposes, this is approximately 0, negative 5.31, and 0, 1.31. Now we can create our finished graph of this ellipse. What we do first, graph the center of the ellipse at 3, negative 2, and then from there, we can graph our foci, our major and minor vertices, as well as our major and minor axes, and then our x and y intercepts. And we just draw the elliptical shape through all of the vertices and intercepts, and there you go. Finished graph of this ellipse. But anyways, that's it for today's video, guys. If you liked it, please like, comment, and subscribe and all that. And I'll see you guys in the next one. Adios.